Who's your date? Let's tell her to get a new one. That's true. Okay. 2-5, guys, is long division. Okay? We're going to be doing long division. So first off, what I always like to start with, though, is what is long division? Some of you guys might have not learned long division. So I'm going to put one up here. Give me a number. 15. All right. We're going to divide, okay, 1, 3, 5, 7, 9, 1, 0. I don't know. Really? I got to find out where you live. That's more creepy. I like it still. Okay, so if you understand the process of long division, you're going to understand the long division process with polynomials as well, because it's the exact same idea. Okay, so what we ask ourselves is this. We have to understand the idea. Key thing, I'm not really caring about what this answer is right now. Understand the concepts of what you're doing here, okay? Okay, when you divide, you say, can 15 go into this, right? Or 15 times what gets me close to this, correct? Well, I can't here, I can all of a sudden get it to here, can't I? Okay? Is everybody there with me? How many times can 15 go into 135? 9 times. Okay, because that gets me exactly there. Now, what is the process here? Go ahead. Exactly. Now, you guys might already know that, but I want you to understand the process. So we go ahead and multiply, right? Exactly. 9 times this is 135. Right? Everybody remember that? What's the process now? Well, where did you get a 0? I have 135 and 135. So we subtract, right? Therefore, that switched that guy's sign, correct? Does that make sense to everybody, what I'm saying by that? See how it switched his sign? Because we didn't say 9 times 15 wasn't 100, it's not negative 135, it's 135. So we have to make it opposite. Okay, and 0, we bring it down. Oh, 15 can't go in there, so I put a 0, right? Then I bring down the 9. And how do I get to bring down a digit? Is by putting something up here, correct? How many times can 15 go into 79? 5 times. Okay? That is 75, by the way. And I subtract again, and that becomes 41. How many times can 15 go into 41? Twice, and I go 30. That's 90. We can go 7, can't we? So that's a 5, 105, with 5 left over. So that's remainder 5 in a way. But what's another way I could write remainder 5? Instead of R, this answer R5. Plus, I could say plus 5 fifteenths, right? And 5 fifteenths is the 1/3, but in our case, it's 15, 5, that reduces that to 1/3. Isn't that what we did? Isn't that the same kind of concept? Is everybody comfortable with what I just did there, that you're not freaking out? Exactly. And it's okay, because somebody said that you could use a calculator and you got dumb all of a sudden. I'm not saying you did, but right? But that's the reason why you guys never did it anymore. I'm using this book, because this book does pretty good. Say what word? Pre-calculator. Okay. So, here is my first example for you. Like I said, this is the exact same class. Now, here is the question to you. Okay? How does x squared plus 3x plus 5, how is that divided by x plus 1? We're going to do long division. Okay? You set it up the same exact way. Hopefully today is comfortable for you. It's just slightly different. Okay? So, I still put the number, because remember, if I had that, it was that 1,375 divided by 15. The 15 went outside, this guy went in the house, right? Make sense to you? Okay. So I have x squared plus doing this, you basically say the same thing. If we think about the process, what we did last time, we said this. How does x plus 1 get equal to x squared? How do I get there? I need to times that by x. Why am I timesing it by x? Because x times x gives me an x squared. Does that make sense to everyone? Okay, so I times. What's x times x plus 1? X squared plus x. What did we do at this step for long division? So subtract. So when I subtract, I have to, once again, subtracting is adding the opposite, right? So therefore, this is a subtract, so I can subtract and make these both negative. Key thing is you got to switch the sign for both of them. Okay, or however many terms you have there. Some people just do it to the first. But technically, you're going x squared plus 3x minus x squared plus x, and so that distributes through, doesn't it? Does everybody understand what I'm talking about here? Anybody have a question on what I'm doing? Okay, so then I subtract. It becomes 2x plus 5. Just like we did normally, right? These guys canceled out. 3x minus x, 2x, and I get to bring down the next term, don't I? Just kind of like we did in long division, right? Anybody have a question so far? Now say to yourself, how does x become a 2x? I get it multiplied by 2. So 2 times x is 2x. 2 times 1, 2. But what do? I have to change the signs because I am subtracting. That gets rid of it, and it should, because we're making it exactly like him, correct? And 5 minus 2 is 3. And can x go into 3? No. So therefore, that's kind of like our remainder. And how did I write that remainder? I did it as a fraction, so I did plus my remainder over what I divided by. Ladies and gentlemen, that is long division of polynomials.
How's it going to work that past?
I'll get the thing to say exactly. Okay, so then if you have, oh, if it's like 2x plus 3?
Yeah, how would it be different?
It would be different because how does 2x become x squared? 1/2 x. So you're going to have to think about the fraction about how to get to that coefficient. Does that make sense? Does everybody understand what his question was? He said if this was 2x plus 1, for example. How does 2x become x squared? You'd have to multiply. How does 2 become a 1? 1/2. How does x become x squared? You get the idea, timesing by x. Everybody there with me? Are we comfortable? Here's what, oops, wrong one. I have it somewhere. Oh, there it is. Okay, it says divide each using long division. Check your answers. I'll show you how we can check it. Determine whether each binomial is a factor. I'm going to show you how to do that. Divide using synthetic. We're going to show you how to do that. Use synthetic division and the remainder theorem to find P of A. I'll show you how to do that. Divide any method. Divide. Determine if each binomial is a factor. Use synthetic division. Use synthetic division. Okay. Now, how can I check my work? Let me show you. Okay, so notice I have x plus 1. What was the next thing? All right, here we go. X plus 1 times x becomes x squared plus x. Does everybody understand that? I took him and multiplied it to that guy. Took the binomial and turned it just to the first term. Check yes, no. Binomial, first term. Okay? Binomial to the second term, I get, plus 2x plus 2. Anybody have a question there? Everybody with me on that? Yep. This is a good way to check, because notice isn't how when we did division, like 16 divided by 4 is 4, so 4 times 4, if I check, should come back to be 16, right? And then notice last thing, times this guy to this guy, don't the x plus 1 is just cancel, and I have just a 3. Right? And notice that is x squared plus 3x plus 5. Isn't that what I have? It shows us that we can check, right? Yes, sir. You can do it to all of them, but the reason why I'm doing that is so when I get to this term, I can just cancel. Does that make sense? Everybody there with me? Ready for another one? Okay, next one. Any questions? Do you feel that was hard? Okay, next one. This is a great one. Okay, this is also kind of proving us our theorem here. How I'm going to go ahead and divide x cubed minus 1 by x minus 1. I'm going to divide by x minus 1. So just to let you know, we can kind of already understand because we know what our theorem is. Okay, what should this answer be? Well, let me help you out really quick. This is a difference of cubes. Somebody help me out with my difference of cubes. That becomes x minus 1 times x squared minus x, plus x plus 1, right? Okay, this should be my answer. Because if I divide him by him, this is what's left over, correct? Does that make sense? Let's write it as numbers if you don't. If I had, okay, what is 54 divided by 6? Well, is it 6 times 9, 54? I just wrote it differently, so therefore isn't my answer going to be 9? So therefore, if I'm dividing x cubed minus 1 by x minus 1, that's x minus 1 times some number. This is going to be my result, right? Now let's go do long division and make sure we get this result. Okay, is everybody good with that? Yeah. All right, here we go. Okay, so I have my x minus 1. Now this one's a little trickier though. Okay, I have x cubed. Then what's my next number? Plus 0x squared. You have to fill in things that aren't there. Do I have an x value? I didn't, so I have to put a plus 0x and then a minus 1. Okay, so notice, once again, it was x cubed minus 1, right, Maddie? So was there any x squareds in that term? No. If I had a 1 right there, what's 1 times x squared? So therefore, I'm marking as a spot, but technically I got to keep it the same value, right? And what's 0 times x squared? 0. What's 0 times x? 0. So I still have x cubed plus 0 minus 1, which still gives me x cubed minus 1. I just have to have it for a place value. Does that make sense? Everybody with me on that? That is a big step a lot of people forget to see. Make sure you always decrease every power. Okay? Yes, sir. Yes. You have to do it. Or not, you're going to lose something. Because watch, I'll show you right now why. Okay? How does x become x cubed? X squared. I need an x squared, don't I? When we go ahead and multiply x squared times x, x squared times a negative 1. So therefore, I need a placeholder. Okay? And sometimes if you don't have that placeholder, you can get a little bit nervous. So then we go ahead, because we are technically subtracting, I switch my signs, right? And that becomes just an x squared, and I'm going to bring it down plus 0x. Everybody there with me? Anybody have a question? Okay, how does x squared become, x become an x squared? Plus x. Is it following the answer that we believe it should be? It is, right? X times x. X times negative 1. Switch your signs. And I get x. Drop it down, minus 1. How does x minus 1 become x minus 1? Switch. And notice it's the exact same. Oops, you guys need me to come up? Oops, no problem.
So, this is just right here, it's just x squared plus x.
If you're dividing, you would just do that answer, right? Okay. Everybody good? You feel okay? Yes, no? do one more, and I'm going to give you a shot at it. Okay? This one's just a little bit harder. And I'm already going to put it into Italic style here. If I had 2x to the, oops, sorry. I already said I couldn't do it. 2x to the 4th plus 4x cubed minus 5x squared plus 3x minus 2. We're going to divide that by x squared plus 2x minus 3. Slightly different. This time, notice it is a binomial, correct? Everybody see that? I mean trinomial, excuse me, thank you. This is a trinomial instead of the binomial. I had binomial in my head. Michael, don't you know what? You want to know what you look like today? A gold-gray flower. He looks like Ruffles today. Leather jacket, nice switched hair. I love it. I like that shirt. Mom used to wear that. And you, whoa, see look. And you guys could be dates almost because you're almost all in black. You like to be in? I'll shut up again. I thought it was great. Okay, I'm going to push pause. I'm going to give you guys a second to do this. Start checking your work. How does x squared become 2x to the 4th? And what I personally like to do is I always like to put it over its thing, over like 2x squared, so x squared, trying to put it over where it belongs, right? That's me personally. So now I got 2x squared times x squared, that is 2x to the 4th, plus 4x cubed, minus 6x squared, right? Then I go ahead and switch my sign. Boop, boop, boop. Hence, different colors make a little bit of difference, right? Yes. Okay, gone. Gone. Boom. Okay, so now I just have x squared. I automatically get to bring him down, don't I? Okay, so plus 3x, and because that's a trinomial, I'm going to bring him down as well. So then you say to yourself, self, how does x squared become x squared? 1, and the reason being I don't have an x term is because that guy vanished. It would have been this one right here, right? And because it hit both of them, that's why I got to skip a step basically. Does that make sense to everyone? And then we go ahead and multiply through. That'd be x squared plus 2x minus 3. Switch them. So therefore I get x plus 1. So your final answer would be 2x squared plus 1 plus x over and that would be the final answer. Because there's a remainder, right? Where at? So this area right here? Yeah. Okay. So what's in? Did you get the 2x to the 4th plus 4x cubed plus 6x, minus 6x squared? Yeah. So then we switch the signs because we're subtracting. Okay. So therefore gone. This one's gone as well. Right? And then we just get there, and then we can bring down these guys. And the reason why I brought down both is because that's a trinomial, so I want 3 terms with me. Does that make sense? And then I say, okay, how does x squared become x squared? Hey guys, stick with me, please. Because maybe this answers some questions you might have. How does x squared become x squared? Because this guy can't do that. Let's just assume, though. Let's just pretend here. Let's just say this guy came out to be a 3x cubed. Let's just pretend that. What would you do? You'd say, how does x squared become 3x cubed? Put a 3x there. You do the whole process again. Subtract, and you get down to the x squared. Does that make sense to you? All right. Let's go back to, if you'll notice, what was our very first example? Hold on, I'm going to make it nice. Here we go. Let's do the x cubed thing. This time, bear with me. It's actually, you'll like synthetic better than you're going to like long division. Promise you. Have you done it before? And you would prefer synthetic, right? Okay. It makes it so much easier. Okay. So what we're going to do is this. I'm just going to write just the coefficient. Okay. Now once again, if I don't have a term, I still need to have a placeholder. Okay. So what's my leading coefficient? 1. Okay. What's the next coefficient? 0. The next coefficient? 0. The next coefficient? -1. Does everybody understand that?
I would say,
Huh? Just write the coefficients of the term. Okay. Now, understand, synthetic division can only be done when you're dividing by a binomial. Okay? It can only be done when you're doing it by a binomial. Everybody there with me? What value makes this guy 0? It's 1. So what I do is I put a 1 over here. Okay? That 1 is from the value that makes the binomial 0. Okay, me personally, the book, I think it has it look like this. They might put like this. I personally, I put a line underneath, and I'm going to show you why. Okay, the line, because no matter what this coefficient is, you're going to bring it down. Okay, and that should make sense, because once again, I'm dividing by a binomial, correct? And this term right here, even when I solve it, so even if it was like 2x minus 3, what would be the value here? That would make this guy 0. 3/2. The way in synthetic division would be writing this as x minus 3/2, not 2x minus 3. They mean basically the same thing, but when you go through, I want to ask this question. How does an x become an x squared? X squared. There's going to be 1. And no matter what, this is going to be the same value. If it was x, how is x going to go into 3x to the 4th? 3x cubed. You're always going to use that same coefficient, aren't you? Does everybody understand why they always bring him down? You always bring your first term down. Am I explaining it good? Yours might be a little different the way it looks, and I'm okay with that. Yep, that's fine. Like I said, this is the way I was taught, this is the way I show it. Okay? All right, here's what you do. You go ahead and say, guys, what's 1 times 1? 1. So you're going to multiply here. And whatever you get, you're going to put it there. 1 times 1 is 1. And what did we do in long division after we multiplied? We subtracted, but in this case, because I went ahead and switched it from a negative to a positive, I'm going to add. So what's 0 plus 1? 1. So therefore, here you add, here you multiply. Okay? 1 times 1?
which
1. Okay, I'll show it one more time. So first step, bring him down. I'm just going to talk over it. First step, bring him down. Multiply. 1 times 1. I get the answer, and that is 1. I go ahead and add, and I get my new answer, 1. So now I'm on this stage, and I go 1 times 1. 1 times 1 is 1. What's 0 plus 1? 1. What are we going to do again? Times it, what do we get? 1, and this gets to be a 0. Yep. Okay, now I got a question for you guys. What was this? This was 1x cubed. And I divided it by x minus 1. So therefore this is an x squared. Because how does x become x cubed? X squared. So that is 1x squared plus 1x plus 1. Is that the same answer as you guys received the last time? It is. My lady. No problem. Okay. Now if you think about it, we're dividing technically still, right? This is a different style of dividing. So therefore, if I divide by something raised to the x, what's the highest term going to be on my answer? It's always going to be 1 less degree. Okay, if it was x cubed, we're going to come down to x squared, because x cubed divided by x is x squared. Does that make sense? If it was x to the fifth, what would this be? X to the fourth. Does that make sense? And then notice, ladies and gentlemen, we have the rest of it. How do I know if it goes in evenly again? If there's a 0 on the end, it goes in evenly. You have no remainder. If there's like an answer still here on the end, that would be like your remainder. So like didn't we have one with a remainder on the very first one? Can somebody tell me what that one was again? Plus 3x plus 5, and we're dividing by x minus 1 again. Oh, nice. So it's a little bit different on this one, right? So let's go ahead and do the same process. Let's go ahead with our coefficients. What's our coefficients? 1, 3, 5. Okay? Everybody there with me? Once again, what value? So I like to once again go like this. Oops, I'm trying to a little bit lower. I make my bar. Tell me your name again, ma'am. Lexi, she does it a little bit different. Do you do like the little box thing? Yeah. That's fine. Can you come and show me how you write yours? Do you mind? Just so you guys understand, when you see it a different way, it's the same thing. So just kind of over on the side. That's what you do. Okay. And then basically the same thing. So she kind of puts her number right out here in this box. I've seen that before. Me, I just put my number right here. You guys see how it's the same thing? And basically the reason why I do this pushes me down already. And so I'm going to erase this, but everybody see kind of how similar in between the same. You guys can do whatever way. So if you go like maybe on Khan Academy because I'm a horrible person, which I don't think I really am. Maybe you think I'm a scallywag, but he might show it differently. I just want you guys to be okay with it. Okay. How did I get the -1? Once again, where did the -1 come from? The value that made this guy 0, right? Is everybody okay with that? Okay, so once again, we do our process. First thing we're going to do, when I divide, how does x go into x squared? 1x. So it's still going to be a 1 because it's always going to be that same coefficient, right? Does that make sense to everyone? 1. Okay, what do we do? Multiply. -1 times 1. -1. So we add again. What do we get? 2. -1 times 2. And it comes out to be 3. Did it go in evenly? So therefore there is a remainder. This was an x squared, so what does this represent? An x. So this represents x plus 2 plus 3 over x plus 1. Is that not the same answer we received on the previous time we did this problem? No, just any number other than 0. If it's 0, it goes in perfectly, right? Does that make sense? Okay.
Does it change anything if your first coefficient is what?
5. Keep going on the 5. Because how does x go into 5x squared? 5x. Still going to have the same coefficient. Sir, I'll answer your guys' question. Okay, once again, it's the value that makes this guy 0. Make sense? Ladies. Sorry. I can help you. There you go. X plus 2 plus 3 over x plus 1. You got the same thing. Okay, how we feeling? Okay, how do I tell if it's a factor? So if I say, okay, let me think of one. So like this guy. Let's do number 1 on the bell quiz. I had x cubed plus 2x squared plus 5x plus 10. It's going to say, is x plus 2 a factor? Is this a factor? How do I check? Good old synthetic division. You guys ready? Yeah. I'm going to show you. Synthetic. 1, 2, 5, 10. What's the value that makes this guy 0? negative 2. So therefore, I plug in negative 2. Oops, I thought I left that. Bring down the 1. Negative 2 times 1. Negative 2. 0. Negative 2 times 0. 0. Bring it down. 5. Negative 2 times 5. Negative 10, I get a... Is it a factor? Yes, because I ended up with a 0. If I ended up with a 1, is it a factor? I will tell you something, though, ladies and gentlemen. If I end up with a 1, guess what I know? It's called the remainder theorem. It's called f of negative 2. If I plug in this equation, and let's just pretend this came out to be 1, it would equal 1. Like, let's look back on the previous example we just did here. Okay? If I find f of negative 1, let's not even worry about this. But notice, what did I end up with? I got 3, didn't I? Okay? Plug it up in here. What's negative 1 squared? 1. 3 times negative 1 is negative 3. So we have 1 minus 3, which is negative 2, plus 5. It's 3. If you do synthetic division, you can always find a point on a graph. And that should make sense, ladies and gentlemen, because think about it. If it ends up 0, that means I plugged in negative 2, right? And what did I get? 0. It's a factor, meaning it is a 0. So the same kind of idea. I plugged in negative 2 into synthetic. I got out a 0. No problem. All this is as well, the remainder theorem tells us whatever our remainder is. So if I go into 0, that's awesome. That means it's a factor, right? That means also on my graph, if it's called a factor, it's called a 0. And where do we cross the x-axis at? It'd be a point, so at negative 2, but the y value would be 0, right? Okay, so on my next problem, or my previous problem that I had here, if I plug this in, and it's not, okay, when I go ahead and plug this in, watch what I do then. Okay, when I plug this in here, that negative 1 gives me the same thing as my remainder, hence the remainder theorem. Whatever the remainder is going to be the result. So if it doesn't go in evenly, we can still figure out something nice. So, just a curiosity, okay? If I had 2x cubed plus 5x squared minus 7x, okay? So notice you would have 2, 5, negative 7, and 0. We know for sure what value works. 0, and that would give me 2, 0, 5, 0, negative 7, 0, 0. Look, it worked, huh? And what does all these guys have in common? An x, so I have a 0, right? And then now I say, okay, now that's 2x squared plus 5x minus 7, and I can keep going as well. This will help us find other zeros.